In Claris products, it isn't quite necessary to know the entire background of JSON to use it in their products, but it might be good to know about the reason for JSON existing. In this section, we will cover the reasons through the 5 W's and how. Then, when knowing this, you will have more ideas to implement this in your projects to increase efficiency and organization. So, who uses JSON? Well, JSON started in the year 2000 by Douglas Crockford, who wanted an easy format for data to be transferred between systems. This was originated from JavaScript, which is generally used in web applications. Therefore, many web developers use JSON. It has since been adapted to use in other places, so developers for other applications would also use JSON, such as FileMaker developers, for example. What is JSON? It is a data transfer text format. Not much more complicated than that. Basically, it's text that is formatted as JSON, or in other words, text that contains JSON. Many things use JSON, but it is not a programming language, so it's not directly used to build applications or web pages. It is, however, a subscript of a programming language called JavaScript, which, by the way, JSON stands for JavaScript Object Notation. Not necessary to know any JavaScript to use JSON, though. What it is good to know is that JSON is built on two structures: a collection of name-value pairs, and an ordered list of values. Where is JSON used? Obviously in web technologies, but instead of explaining all those technologies and where in those technologies JSON is being used, we will focus on Claris products. There are specific places in Claris Connect and Claris FileMaker where JSON is being used. That would be the data utility type in Claris Connect, the insert from URL script step, the data API, the web viewer with JavaScript, and JSON functions. When is JSON used? We know where JSON can be used in Claris products, but it is not always used in those places. When it would be used in those places is to transfer data, and generally that is done through passing a parameter. In computer science terms, a parameter contains pieces of input or data that can be used when it is passed to someplace else. This place is usually through URLs or functions. For URLs, in terms of JSON, it is often used for APIs. And for JavaScript, it has its own sets of functions that differs from FileMaker's set of JSON functions. Why is JSON used? We covered that it is used to transfer data and that it was made because of a need for a structured but simple format. Now, why this format is used as opposed to other things that exist is because its only purpose is to transfer data and nothing else. Also, it just became really popular above other data transfer formats. SQL and XML are both languages, while JSON is a subset of a language. When we look at SQL, or Structured Query Language, it queries a database to get a list of values. It gives a list of values, which can only do so much. And XML, Extensible Markup Language, is human-readable, but its structure can be more complicated because there is more flexibility in how it is formatted because it is a markup language used with attributes, like in HTML. There are other formats for transferring text, but JSON happens to be a popular one at this moment in time. So how is JSON used? With how JSON is set up and formatted, many applications and programming languages would have their own way of reading JSON. As I have said before, JavaScript has its own way of processing and parsing JSON, which, again, we don't need to know since Claris products, specifically FileMaker, has its own set of functions of how it parses JSON. We covered where and when JSON is used, but the specifics of how it is actually implemented in various languages and applications. To summarize the answers to the 5 W's and how questions and the reason for JSON existing, it's used by many systems outside of Claris products as a data transfer format, which allows easier integration, hence a reason to use this format. Plus, using it just within the Claris FileMaker platform can make your system run more efficiently and cleanly by its structured format. JSON can handle simple data but has the flexibility to handle information that is more complex and still be human readable. JSON, since it is structured and transfers data, it carries certain types of data. When it carries certain types of data, it needs specific syntax to keep in line with the JSON format. How JavaScript interprets data types is a tiny bit different than how FileMaker JSON functions do it, but this helps the data keep its own structure and not be lost by being reduced to more simpler characters. Therefore, it is important to know about JSON data types and the syntax to use them. There are 6 of them, 2 being more complicated than the others. In order to understand the data types I talk about in this section, we should know about recursion. You may know already about recursion by using or creating custom functions in FileMaker. Because some data types refer to other data types, it may seem circular, but it's actually iterative, much like replacing variables in algebra. And generally, this applies to the data types, objects, and arrays. These are the 2 structures JSON is built upon, and as I have said before, at its basic structure, it consists of name-value pairs or ordered lists. These name-value pairs are in an object. The ordered list is the array. They both contain values. Another thing I would like to mention is whitespace, which consists of spaces, line feeds, carriage returns, and horizontal tabs. For the most part, it doesn't affect much in JSON, but helpful to have to read JSON in an easier manner. There are only a set amount of data types in JSON: object, array, string, number, boolean, null. And these types are also known as values, which again you will learn more about in this section. As I've said before, objects consist of name-value pairs. Name in an object is always a string. A string is a list of characters. Value in an object can be many types: an object, array, string, number, boolean, and null. And the pairs are connected with a colon, and each pair is divided by a comma. Around the object are curly brackets. An array consists of many values that are divided by a comma. By this time we know what values consist of, and now we can see how this can cause recursion, since values can be objects or arrays that contains even more values. Also, in the list of ordered values, the count starts at 0 instead of 1. So in this example, even though there are 5 values in the order list, it counts from 0 to 4. That is important to keep in mind when referring to values in an array, since they all have the same associated name, which is what JSON uses to get the value. So let's move on to the next value, string. This is used for a name in a name-value pair. A stream consists of repeating Unicode characters that are surrounded by quotes. Examples of characters, although not limited to, would be alphanumeric like A through Z and 0 to 9. Fortunately, we cannot include emojis. I'm sorry. Even though JSON can include many characters, some of these characters need to be escaped, as well as things such as 4 hex digits and whitespace. By escaped, I mean that they are interpreted as what they actually are and not part of the JSON formatting. There is a reverse solidus or a backslash right before the character that needs to be escaped. And this only applies in the context of a string, so there would still need to be quotes surrounding the characters. A number consists of digits, signs, decimal points, and exponents. Digits are 0 through 9, which can be repeating as long as it doesn't start with 0. Signs is a plus or minus, which you cannot use a plus sign at the beginning of a number. Decimal point is the period between two numbers to signify a fraction. And the exponent is a type of number expressed with the letter E, and it encompasses both the plus and the minus sign. A Boolean value consists of either true or false. This can be represented a little differently in terms of Claris FileMaker JSON functions. A null value is literally a representation of nothing, but it is represented by the word null. That also can be represented a little different in terms of Claris FileMaker. So when we put this all together, we can create text in the format of JSON. We can see that it can be simple, but grow into something larger using recursion for the values. In this recursion, it makes levels within JSON text, which is a process called nesting. These levels have some significance in terms of FileMaker JSON functions. When white space is added to text that contains JSON, it makes it easier to see levels. It happens when values are expanded upon by nesting objects and arrays within each other. And if we look closely, we can see that objects, not arrays, are the ones that determine the levels. But if a new object is nested into an array, then it carries the array to the next level. You can play around making JSON text in online JSON formatters, although I would note that I have found the formatters to be a bit more strict in the formatting of JSON than Claris FileMaker. I know that of this structure for JSON formatting may seem like it has a lot of complex syntax to remember, but if you remember the 6 value types and each rule for the data type, then breaking it down may not seem as much to handle. The most complex are objects and arrays, but those can be broken down, and to make it easier, do it by level by level. Now that we have an idea of what JSON is, its structure, and how it's used, let's look at where it's used in the context of Claris products. I will split this up into 3 categories. The first category is the URL, a Uniforce Resource Locator, or web address as it is commonly known as. JSON is used as a parameter that is passed through a URL. The places where it would use a URL is the data type utility in Claris Connect, insert from URL FileMaker script step, and the FileMaker data API. They all use URLs and potentially therefore can use JSON as a parameter. The next category is JavaScript in a web viewer, which JSON is a subset of that language. There can be code put into a website as HTML, and within that there can be JavaScript. This is particularly useful for FileMaker add-ons, and there is also a script step, perform JavaScript in a web viewer, which will perform JavaScript, which one of the JavaScript's function is JSON.parse. Then the last category is the FileMaker JSON functions. Those are called in the calculation engine, which is located in many places within FileMaker. Let's look at where some of these are. And here we have Claris Connect, which if you go to connect.claris.com, that's where you can access your solution. We have a list of my projects here. We can click one to open up and edit flow here, which flows would be consisted of different things like triggers and actions that have this function. We have a list of flows here. Let's create a new one called test JSON. Choose create. And if we scroll down here, we can see that JSON is a potential possibility. Now it's sort of faded out here because we can't use it because we need to actually call something before that for it to function on. So let's choose FileMaker. Now we already have a thing that says script trigger. We can click on the plus, click on the action. Now when we scroll down, we can see that JSON is in here. So it'll add this to the flow. We'll press continue. We'll enter the JSON. It'll save it, review the test, and that is how the data utility is added. Another potential place we might see JSON in here. Let's go to our example test on premise. We'll see that we have incoming HTTP request. If we click on that, we can see that it wants a webhook, and the webhook it basically is in the form of a URL, and that URL can have JSON in it, which it does say here, reply with JSON. So that's a couple places in Claris Connect where JSON is useful to know. In FileMaker, let's look at examples of where it can be used in this product. Let's open up a file. We see that we have different objects on it. Well, the first things we will see is a web viewer. If I go into layout mode, we can see that this web viewer has some scripting in it. Let's open this up to take a closer look at it. So what's in this web viewer is data text HTML, which tells the web viewer we want to put our own customized HTML in it. And then after that, we can actually start with the HTML code. Now within HTML, there is a script tag. And within a script tag, we can use JavaScript. Here I have a little bit of JavaScript here. I created a function, JSON JavaScript function. But remember that for later. And then here I have JSON that I coded. JSON itself won't have these escapes. That's here with FileMaker, because in FileMaker you need to escape quotes. And then we can see within JavaScript it uses the function JSON.parse to get the JSON information. And if there was more JavaScript in here, we could use that information with the rest of it. But that's an idea of where we can use it in a web viewer. So let's go to our next where we can use it. So let's look at some script steps. Opened up the script workspace. That's where we'll create scripts that FileMaker uses. We already have some scripts here to do some functionality. But let's look at a couple of script steps that would potentially use JSON that would include the URL. So first one, which is very popular, is insert from URL. This basically gets information from a different website or page and passed into it, so when we double click on it, it says field or variable, and whatever information we are getting, it's stored into one of those. If we click the gear here, we'll see different options. When we click on specify URL, this is where we can actually put in the URL. This has the calculation when you click specify. And like I said before, when we have our URL, a URL can possibly have a parameter at the end of it, and that parameter can hold JSON. Another script step I would like to look at is execute FileMaker Data API. This is the script step, which is different from the FileMaker Data API, which is used by external applications to get information from a FileMaker file. But we have here the script step, and if we click the gear here, the target, which is like the insert from a URL, where it has the field or variable from the data that it gathers, that's where it would go into. And then the request, which would be the URL, and in the URL there would be parameters, and those parameters could be JSON. So in a little different path from URLs, they actually have perform JavaScript in a web viewer. This doesn't have to do with URLs, it has to do with, like it says, a web viewer. When we click on the gear, it says an object name that would be of the web viewer that is holding the JavaScript that we wrote. As we can see, if you remember the web viewer that we did look at, we can use that as an example. And for the function name, remember the scripting in that web viewer function that I wrote that was called JSON JavaScript functions. And that would be put here. And in here would be the parameters, which could be different things. But for our purposes here, it could also be JSON. So those are some script steps that could use JSON. Let's look at some JSON functions. We'll use a variable in a script to do this. Let's just call this JSON. And we'll open the calculation engine here. In here, if we start typing JSON, you'll see the list of all the JSON calculations. So start with JSON set element, JSON list values, JSON list keys, JSON get element, JSON format element, and JSON delete element. And generally would you only use one of these calculations at the time, but I put them all here just so that you can see what they look like with the different parameters, which you can just double click and replace it with what you like. But this is to get an idea of how to get to these calculations within a script. So when you look at the calculation engine, you can see that the list over here is tables and the fields within the tables. But over here, if we click this, it is where all the functions will be. And if we type in JSON, it'll list the functions. If we click on each of the functions, it'll give a description down at the bottom of a little bit of what the function's purpose is to help you out. So again, places where JSON can be integrated in Claris products as a data type utility in Claris Connect, and in Claris FileMaker there are the insert from URL script step, the data API, the web viewer with JavaScript, and the JSON functions. With knowing JSON functions, it can be used within FileMaker without having to know another scripting language or application. The JSON functions can create or build JSON, and when that happens, the result of JSON text can be used within FileMaker. But also, since the result is in JSON text, they can be used in other places I have shown in this video, because they all can use JSON text. So even if JSON functions are good to know as a baseline, it's also good to have an idea where else it can be utilized. In order to understand the Claris FileMaker JSON functions, we should understand the parameters. I'll be talking about the parameters without the context of the functions, since they are used similarly throughout all of them in which they are utilized. This is also may help in the thinking about how the functions can coordinate and work together. And I will talk about the parameters in a different order than they are presented in the functions by building to understand how the parameters work with each other. Type is the type of value being passed into the function. Value being another JSON function parameter, which we'll talk about next, but type not only helps JSON to format the data, but also helps FileMaker to format the data. The only JSON function that uses the parameter type is JSON setElement. The other functions don't really need to know the type for those to work. The type parameter in a JSON function is hard-coded text without quotes. The data types are being used corresponds with the 6 types that I've gone over in the data type section, although they may be treated a little differently in accordance with FileMaker. Along with a new type called JSON raw, which is not part of the original JSON data types. That is because it works a little differently than the other types. It's what JSON functions defaults to if it can't detect other types being passed. It will try to then determine what the type actually is if the data is in the format of valid JSON. But otherwise, if not, it will turn the data into a string. So basically JSON string. For the value, this is the information being passed into a function. We have talked about the types of data, but this is actually the data itself. So it's important that this information gets through since it is a value in a name-value pair. This parameter is also only used in JSON setElement. The other functions will definitely use the values, but since it is a name-value pair, then all they would need is the name and not the specific value. Value can come from a field, variable, or hard-coded text. The way those are entered is similar to other FileMaker functions that have parameters. Within a field, it can contain many things, but make sure those things have an associated data type that JSON can handle. The parameter, JSON, is the text that contains JSON. To edit existing JSON, it needs to be valid JSON that is passed into the function. And by valid, I mean correct JSON formatting. And in FileMaker, it can be as simple as 2 curly brackets. Otherwise, there should be no text if new JSON needs to be created. If there is text and it is not valid JSON, then it will report an error. All the JSON functions use this parameter since the text with JSON is what is being operated on. So it's important to know about this parameter. Luckily, the format is not too complex. Which leads me to where JSON can come from. It is also a field, variable, or hard-coded text, and they must all have text that contains valid JSON or be empty. Note, when using hard-coded text, there are certain characters that need to be escaped within FileMaker, such as quotes. The key or index or path. This parameter being passed is the location of where the value will be in the text that contains valid JSON. When I talked about levels and nesting in the data type section, this parameter is where that needs to be considered. All the JSON functions except for JSON format elements use this parameter. When we talk about name-value pairs, we can think of this as the name part, only the name can be more complex than a string. JSON text can come from a field, variable, or hard-coded text that contains valid JSON, but would note that it has specific FileMaker syntax. Hard-coding text still follows the same syntax of escaping characters like quotes. And the thing to know would be how in a text this parameter points to a certain place in the JSON. Let's break down the parameter name. Key is the name of the key in a JSON object. Index is the index of an element in a JSON array. The first element has an index of 0. Path is a hierarchical string of key names, array indexes, or both. In this parameter, these can be combined in different ways. This is what will specify different levels of JSON. And the path is basically that combination. In this example, we have the JSON object bakery. When we address the entire object of bakery, it is a simple string. But when referring to the arrays and nested objects of JSON, these are also valid parameters to pass within a function. There are only 4 parameters to know in the JSON FileMaker functions, but not all of them are used in every function. They still each have their own purpose, but how they are formatted and used is important when passed within each function. The JSON FileMaker functions all have their individual use that we'll cover in this section, and then we can see examples of how each one are used. I covered what the parameters of JSON are in the parameters section and which functions use them. Here we can see an overview of what that looks like and the parameters in the functions. The parameters being JSON, key or index or path, value, and type. Our first example we are doing is JSON setElement. And the reason for this function is to create a JSON element or to edit a JSON element. And when I say create, I mean creating text that contains JSON, and with editing, there's already text with JSON in it, so we would just be changing values or some other element within it. We'll start by looking at how to edit JSON. We have the variable with the $sign that is called JSON that has the input of name and donuts, a name value pair in an object, and that's going to be put in the first parameter. And next to would be the name value pair within JSON setElement, and in this case, in this function, it's category and breads. And the last, of course, is type, which is JSON string, coordinates with breads, which is a string, as you can see by the quotes. So if we run this existing JSON through the function, we can see the result has both name and donuts along with category and breads. And in this case, it puts it in alphabetical order. But let's say that when we have the input of name and donuts, and in the function, there's also the name that it coordinates to be the same, but the value is different. We can see the result, instead of having the 2 name value pairs, it's just the one name and baguette. So basically it updated from donuts to baguette because the name part matched. You'll see that for JSON set example, the second variable, the key or index or path, that's going to be important. And I'll show you with the other examples of how we can structure those. But let's start with looking how to create JSON. Let's say we want to make that name and donuts JSON. We have our variable $JSON. This time the variable would have nothing in it, because if it did have JSON, that would be editing JSON. And if it had something else that isn't JSON with it, it might create an error when going through a function or have a value of nothing. But we can see that it has name and donuts as the name value pair, and JSON string that coordinates with donuts, that is a string. And of course gives the result of an object with name and donuts as the name value pair. In this example, JSON setElements can actually set more than one value at the same time. This function is unique in that way, unlike the other JSON functions. So we have the values of donuts, $1.99 and 1, with the name of name, price, and special, and the types of JSON string, JSON number, and JSON boolean. So we've seen how JSON string has worked with donuts. JSON number coordinates with the number because obviously 1.99 is a number, and that number is without quotes. And then with boolean, we could put true or false, but generally in FileMaker we deal with numbers for booleans. So 0 or empty is false, and then otherwise a different number would be true. And then when processing it through the function of JSON setElement, we can see how it processes it according to type. The name and donuts are obviously 2 different strings for name value pair. We've got price and $1.99. The price is in quotes, and the 199 is not within quotes because the type is JSON number. If we had JSON string, it would probably be in quotes then. And then we have special and true, which special is in quotes. True is without quotes because it is as the type Boolean that we specified in our function. And again, if it was 0 or empty, it would instead say false. Let's look at how we can create an object nested within another object. We see JSON element here with two different values of donuts and Bakeology. But you can see in the parameter where it would be key or index or path, we have bakery.product and bakery.name. Both bakery and the product and name will all be part of the name part of the JSON, but where in the JSON it's located is differentiated with that dot. When we look at the result, we have our object with the name bakery, and then the value that's associated with it is another object with the name value pairs of name, Bakeology, product, and donuts. So that's how we nest one object within another object. Now how arrays are created is in some ways similar, where we have the name product and then something else, which in this case is square brackets, but in this case we have the numbers 0 and 1. Arrays start their counting at 0 instead of at 1. So when we look at the result, we have the name of product. In the array, there's donuts and chocolate cake as two different values. Now that we looked at how to create objects and arrays, we can see how to combine these two notations to create JSON that has both of them. In this function, like the previous example, we have product with the square brackets and a number in them. In the example before that, we have the bakery and dot. The dot comes first, so that would mean the object would be the first thing that comes, and then square brackets would mean the array comes next. When we look at the results, we have a name value pair with the name being bakery, and then this time we have the value, which is the object, and within this object it has the name of product with the array of donuts and chocolate cake. Basically, we have an array inside an object inside another object. Now in this example, in comparison with the last example, we have got bakery.product and bakery.name. Instead of both being bakery.product, we have square brackets, both with 0 in them. And that means that product and name are both different values that have arrays in them. So when we look at the result, we have bakery as the name and the name value pair. The object within it has two name value pairs within that, so it's two arrays within an object within another object. So let's switch that around, where the array comes first and then the object. We see in the function that we have bakery with the square brackets is 0, that would be the array, the dot, which would indicate that the next part is an object, and then we have product and brand. When we look at the result, again it's bakery, but this time the value is an array instead of the object first. But in the array, it has one value, and this one value is in the object. But within the object, there is two different name value pairs, brand and Bakeology, and product and donuts. Basically, it's an object within an array within another object. Now for this, the only difference between last example and this example is that I changed the number in the array part of the function to 1 instead of 0 for the second line, which will change the result of the value part of bakery. It has an array again, but instead of the one value of one object, it has two values of two objects, and each of those objects has one name value pair. So in this case, it would have two objects within an array within another object. So those were a few examples of JSON set element of how to create or edit text that has JSON already in it. We can see that the main thing we have to focus on is key or index or path. That's partially because of objects and arrays. Objects with the dot notation, and then arrays with the square brackets notation. And a lot of it depends on the order that you put it in, and that's what develops the path part of the key or index or path. The number in the array would be index, and then the key would basically be the name. And then when we see with value and types, with the specific kind of value, you need a coordinating type because as we saw with the Boolean, it changed the 1 to true. So it's important that the type matches the value. In JSON, it can be basically squished up together, but with JSON format elements, it can clean up that JSON, add white space to make it easier to view, so that when we look at the JSON, it isn't that scrunched up. A simple example of this is that we have the input the name value pair of name and donuts into the variable of the $JSON that we pass into the function. It will show the result into 3 different lines, and then there's spaces with name space colon space donuts, unlike in the input there wasn't any white space. But that's pretty simple because it's not too hard to see name and donuts. But in this example we have actually 3 different name value pairs, the name, price, and special. And when we put it through the function, we can see that it separates those 3 different name value pairs on each of their own line. And here we see an array where it has the name product and then the 3 different array values of donuts, chocolate, and cake. Again, we see the values are in 3 different lines, and then the name even has its own line. We can see where the array starts and then where it ends. This is similar with an object. You can see that bakery has 3 different name value pairs in it instead of just values. And those name value pairs again on 3 different lines, with bakery also having its own line. We can see where that object starts and ends. And then when we do something complex with having a nested object within an array within another object, you can see the right has more white space and so much more easier to read the name value pairs and what's nested within what. And one of the advantages of having JSON that's basically cleaned up is that if there's something that's wrong or something that we want to change, we can easily see where that is. Now we have the function JSON list keys. The reason for this is to gather keys from the text that contains JSON, which it can be important to get those for value retrieval. Here we're starting off with JSON that has 3 name value pairs in it, and when we process it through the function, we will get the names or the keys, name, price, and special. And we see within the function that we have our variable with the $JSON that we inputted, but also there's a second variable that has 2 empty quotes, and that's so we can easily list out all the keys within the first level of the JSON, because the first level doesn't have a name. Next example is that we have an object within another object, and here with our second parameter we have bakery with quotes in it. So look for all the keys or names that are within that object, which in this case would be product, name, and brand. As we can see with the name and value pairs, that does associate. This is a little bit different with our arrays. Since there aren't name value pairs, they're just values. What would take place in the name is the index, which would be 0, 1, and 2. We know with arrays it starts the counting at 0. The second parameter in JSON list keys is product, so we know that we're looking at the array and not just the entire JSON. Now here we have the input with the object inside an array inside of another object, and the second parameter, the key or index or path, we have that combined dot notation with square brackets, so we have both object and array because we're trying to get to the innermost part. So the dot means that we're trying to get to the next level of JSON instead of the first, and then the array is indicated by the square brackets, and since it's 0, we're looking for the first value within the array. And within the array we can see that there's an object within it, and in that object there are name value pairs. So it's going to get the list of names within that. Now if we change this a little to have 2 different objects within an array within another object, and we also change the second parameter with the dot notation without the square brackets, so we're looking at the entire array and not an item within the array, just the entire array. It again gets back to the index with 0 and 1 because there's 2 items within the array. Now what if we wanted to get the list of names in a name value pair of one of the items? Well, we go to example of, in the second parameter, we now have included the square brackets instead of just bakery.product. And that'll give you the first value within the array of product. They're both objects, but for this purposes, we're only looking at the first one, and its name and price. This is kind of important if we need to know the names or keys in the JSON that we don't know what's exactly in the JSON. If we created the JSON, we can handle this other ways, but if we're trying to get JSON from other places, we're not sure exactly what all the names are, this is an easy way to get it. And we also don't have to worry as much with the arrays because it gives the index of it. We have JSON that we want to process, but all we care about is getting the values from it. One way to do that is using the function JSON list values. And the way that the variables work in passing to it is similar to JSON list keys. You can see an example, we have the input of the three name value pairs. In JSON list keys, you'd see the result would be name, price, and special, but instead here it's donuts, 199, and true. And the second parameter here, again, is empty quotes because we're basically dealing with the first level. Now with the objects, when we have the second parameter as bakery, and we want to get the values within the object of bakery, we've got product, name, and brand, but the values are donuts, Bakeology, and Sunshine, which will interestingly put it in alphabetical order in accordance with the name. So we see Sunshine first because brand is alphabetically first. Here we have an array, which the second variable is calling product, so it wants to get the values of the array. And it'll simply just give you the values of the array, which is donuts, chocolate cake, and baguette. But let's say that we have two objects within an array within another object, and we want to get just the product array itself. This actually lists the two different objects within that array of product as the result, which might make it easier to take this result and parse that out. But if we want to get to the values, in our second parameter we'll include the square brackets, and we'll include the number, this time being 0, which would be the first value within the array. And the first value in the array is donuts and 199. Now if the number was 1, it would be instead chocolate cake and 22.5. So again, this is just an easier way to get the values, but what you can see from the examples, it not only can just get values, it also can get just inner nests of the JSON in case we don't want to focus on the higher levels of the JSON and just like inner levels instead. JSON get element basically does get just one element of the JSON, and that could be a value or it could be a nested level of JSON. This is similar to JSON list values, but instead specifically gets one at a time. Sometimes we need to only get one value at a time instead of a whole list, or if we need to get more than one, we can use this within a loop, and it can get an advantage of more flexibility than with JSON list values. In our first example of JSON get element, we have the three name value pairs. In the second parameter of JSON get element, we have name. When we look at the name value pairs, we can find the name in it, and then we can find the associated value, which is donuts. So the result would be donuts. When we're dealing with arrays, we have in our second parameter product. So the result here will just be the entire array, since we specify that we want the entirety of product. But if we want one value, we go back to the example with the product and the array, and the second parameter now has the square brackets. It'll get the first value of the array, which is donuts. When we put a number within the square brackets, we'll get the value associated with the index, which 0 would be the first value. That's donuts. We change it to 2, that would be the third value in the array, which is baguette. Here's a combination where we have two objects within an array within another object, and we want to get the whole array of the product. We do bakery.product in our second parameter because within product there are two different objects as values, hence the dot notation there. But when we get just bakery.product, it gives us the whole array. When we include the square brackets within the second parameter, we'll again get the first value of the array, which is the first object that has the two name value pairs. If we put the number in, we can specify a different value within the array. This time it's getting the second object because it's the second value within the array with name, chocolate cake, price, and 22.5. But if we want to get something more specific, we need to add the name within that object afterwards. So bakery.product with the square brackets with 0 indicating the first value within the array. But within the first value of the array of this object, we want the name price, and associated with the price of the first object in the array is $1.99. So for the key or index or path for JSON get element, we can see that the formatting is similar, but it adds the extra name besides the brackets to actually specify the name to get the associated value with it. And that value could be simple data or it could be another nest. And therefore it would get a specific value. But if we go back without the notations of square brackets or dots and we want to just get the inner nest of a certain JSON, this is a good way to do it. And maybe you only want to have certain parts of the nest so that we can deal with one part of a nest of JSON at a time. Let's say we have a bunch of JSON and we don't care about certain parts of it and we want to reuse the JSON but without those parts. Well, we can delete certain parts of JSON with this function instead of having to manually go through it. So in this example, we have the JSON with the three name value pairs. Our second parameter in here in the function is name, which we can see in the name value pairs. That's the first one. So the result, it deletes that name value pair, which is name and donuts, leaving only price and $1.99 and special and true within the JSON object. Now let's say we have an array and the second parameter is product, so we're addressing the entirety of product. That's basically deleting the whole array. So the result will be two empty curly brackets because you're basically deleting everything in it. It doesn't really care about the name product, just the values within it. If we include the brackets without a number, it'll just get rid of the first value within the array. So donuts is gone since it's the first value, and it leads with product, chocolate cake, and baguette. And if we have a number within the brackets, we can specify which actual value within the array we want to get rid of. In this case, we have 2, so we want to get rid of the third value in the array, which is baguette. So we see in the result that baguette is no longer within the JSON. Here you see an object nested within another object. The second parameter is addressing a name, and then it gets rid of the entire name value pairs with it, result of an empty object with a name inside another object. If we want to be more specific, we'll put dot notation. We can see that in the second parameter it's bakery.brand, and when we see the result, brand and sunshine, that name value pair is gone. Similarly, when we have the two objects within an array within another object, when we specify the product array without the brackets, you can see that again it just empties out everything within that object, leaving just an object since it is a dot notation, even though there is an array. When we include these square brackets, it'll get rid of the first value within the array, which is an object here, and then obviously leave the second value in When we include a number within the brackets, it specifies the certain value within the array, which since it's 1, it'll be the second value. So name, chocolate cake, price 22.5 is no longer within this JSON element. But if we want to get more specific than that, we'll include a name. So we have 0 here, so that's the first value in the array. The specific name of price, in which associated with it would be the 199. So the price in 199 has disappeared from this JSON. Again, that's how you would remove different elements of JSON, but if you want to update or create, I would update or edit in a JSON. Instead, I would use JSON set element, or there are different ways to just ignore different parts of the JSON if you don't need it. That's an overview of the different JSON functions and how to use them with the different parameters. A lot of focus is on getting the parameter key or index or path correct, because that has a certain format that it needs. And hopefully, in knowing all these functions can give you an idea of how to create or manipulate JSON to be used within your system or to pass into different systems. I am now showing a couple of other uses of JSON elements with different types to show how JSON elements can add to an existing JSON text. We have an array and a JSON number. Let's save the script and run it to see the output. As you can see, with the new JSON set elements added to the existing JSON text, we have multiple name value pairs now in our JSON text. In JSON set element, we can see here that there are several listed here to add to an existing JSON text. This also can be combined into one JSON element instead of several. We can see that this JSON element has all the other different components of the other script that has several JSON set element steps, with name and Mary Smith, children, and age, but now compacted into one JSON set element into a list. If we run the script, we can see that the output is the same. So after we run the script, we do in fact see that the output is the same with name, children, and age in the JSON text. In using JSON, we will eventually have to retrieve a value from the JSON text. Using that in FileMaker, we use JSON get element. In my first example of JSON get element, I get the name directly in the name value pair, which in this case is age. In my second example of JSON get element, I am getting a certain value within the children array. As you can see that there is 0, it's actually getting the first value in the array, which in JSON is it starts with the number 0 and counts up from there. So let's save and run this script. So again, we see with the first JSON get element, since we directly said age, so we got the value 35 that goes with it. And in the second one, the array, we get the value Sally, which is the first element in the array. Sometimes in JSON, we only need to get certain parts of the JSON text, in which then we can use the functions in FileMaker JSON list keys and JSON list values. In JSON list keys, it takes two parameters, the first one being the JSON we were being worked on, And then the second one will be the key or index or path of which layer of the JSON text that we are working on. For right now, I have it blank so that it'll list all the keys within the first layer. JSON list values is similar, that it takes two parameters, the first being the JSON text we're working on, and the second one also being the key or index or path that we are specifying within the JSON text layer. And again, if we leave it blank, it will list all the values within the first layer of the JSON text. So if we run this script, we can see that the JSON list key does in fact list all the names in the name value pairs of the JSON text, age, children, and name. And with the JSON list values, list out all the values in the name value pair of the JSON text. Sometimes within the JSON text, we need to remove a value. In FileMaker, we'll use the function JSON delete element. With delete element, I have two examples. The first one referencing directly the name in the name value pair, which in this case is age. And in the second example, it will delete the value in the array. Again, it will delete the first one in the children array, since it starts at 0 and JSON starts their numbering at 0. So let's run this script. So we can see after we deleted different parts of the JSON text, they are no longer within it.